Okay, can you guys see my screen?
Thank you.
Yeah.
And
Yeah.
the first
I can
slide.
see it.
Yes.
Yes.
Okay,
Yeah.
awesome. Okay, let's start. So this is going to be module 2, threat management and cybersecurity resources of network security fundamentals lectures. So in this module, you will understand and you will be able to explain what a pen test is. You will be able to identify the rules of engagement and how to perform a pen test. Also, you will be able to define what a vulnerability scan is, and you will be able to describe different cybersecurity resources like the SIM, vulnerability management tools, and so on and so forth. First things first, let's talk about penetration testing. So when we want to study penetration testing, we should be able to define what penetration is at all, and you should be able to explain why do we need to have a pen test, which we will discuss it in the coming slides. Also, examining who should perform the test and the rules of engagement is another goal that we have in the set of slides. And finally, knowing how to perform a penetration test is kind of like closing the loop on understanding of penetration testing that we hopefully are going to obtain at the end of these slide sets. So let's start with definitions. Penetration testing is the attempts to exploit vulnerabilities so that you can uncover the unknown vulnerabilities, provide a clear picture of the nature of the vulnerabilities, and determine how those vulnerabilities could be used against the organization. So basically, as a white hat hacker, you hack into the system, you uncover, discover, and find out what type of vulnerabilities are there that you actually can exploit, and you clarify it for the entity owner or the system owner that these are the possible exploits against your system. And then after that, you let them know that how those can be exploited by a malicious actor or black hats, as we call them here. You have to understand that in order to avoid legal issues, in order to avoid confusions and escape scope creeps, you need to have a plan. The plan that actually sets the initial test limitations, scope of the test, right? How far are you going to go in this test? Are you going to stop at the door, or you're going to just continue going as deep as possible? Think about someone who wants their home network be tested just to see if anybody can break into the security of their wireless access point. But the pen tester not only breaks into the security of wireless access point, but also moves to their computers and look into the file that they have in a hidden folder on their computers, which now creates legal issues because as a pen tester or a white hat hacker, you're only white hat hacker as long as you're within the limits. But if you're touching a system that you don't have the consent of the system owner for the test, then now you're a hacker, you're a black hat, and you can simply be questioned for the sake of what you have done, okay? So remember, the most important step is going to be the planning. So the question to why should we conduct a pen test while we can actually run a vulnerability scan on a system? We do have on your systems, the most simple vulnerability scan tool is the antivirus tools that you install, like Symantec or McAfee that you already have on your systems. Why should you even do it? You already know the vulnerabilities, they're telling you, right? But you have to remember, a scan of network defenses usually finds only surface problems to be addressed. And many network scans that we use, like the antiviruses we just discussed, are automated, and they provide very limited verification of the vulnerabilities. So the automated tools are not creative like a pen tester. They cannot find other tools, other routes around the normal and usual routes. They don't understand social engineering very well, but a pen tester can understand it, right? And so on and so forth. Of course, as we move forward, the companies who are specifically focused on this area, like Splunk or Elastic, those companies actually are developing more accurate and more efficient algorithms, which is revealing even more and more vulnerabilities than before, but we still cannot have as complete vulnerability report as a pen tester can provide happening in the automated tools. So a pen tester can help us finding the deep vulnerabilities and understanding the possibility, that the skills needed, the attempts, right? Like the routes to exploit those vulnerabilities. It's like I can tell you, okay, I have a big building, like a 10-story building that has an unprotected window on 10th floor. Okay, that's a vulnerability, but how do we exploit it? A pen tester can tell you, hey, there are many ways. I can steal a fire truck and use their ladder to exploit that window. Or I can just use a rope and drop down from the top of the building and come down and exploit it. They can find the ways and offer the ways to exploit the vulnerability. And they usually go for the manual techniques. In the previous discussion, we talked about cyberpunks and script kiddies who they actually download an automated tool and they try to exploit a vulnerability. Most of the time, on a well-protected system, when defense in depth is in place, system hardening is in place, and we're going to get familiar with all of these terminologies. For now, just bear with me. When a good security posture is there, the automated tools are not useful because they are known, the way they act and the way they attack is known to the defenders, and defenders already have all the defenses up against those. But a pen tester goes around those with manual techniques, the techniques that your antivirus may not be able to even detect, the techniques that your firewall may not even be able to detect. And that means they can reveal the vulnerability of that antivirus or that firewall for you. So the attacks must be same as those used by a threat actor, right? Considering, okay, what is possible out there? What people can do. If someone with the knowledge of scripting, network, PowerShell, Linux commands, and all that is out there, what they can actually do, right? They should follow the thinking pattern of the threat actors. So this is the gray area that you actually can think about. Okay, now we need somebody who can think bad. So you see the gray hats come to play on this time, right? Okay, someone who can have the mindset of a bad actor is whom you really want to have as the pen tester. So who should perform the pen test? Let's discuss that a little bit. So the first and the most secure and safe group to go to is usually the internal security personnel. Most of the enterprises around us, especially those bigger ones with the good IT departments, they have a pen test team themselves, internal pen test team, right? These guys are hired by the company for whatever reason, whatever qualification they have shown. And the advantage for using these guys is, first of all, the cost is low. So there are big companies out there like Optiv, DeFi, Secure Connect. There are many good names out there that you can give them a project to pen test the system, right? But the charges are huge. Like by huge, I'm talking about pen testing an enterprise network for $70,000 or $65,000 just to run through the network and pen test it, right? So the numbers are big, but when you hire someone, those are your employees. These internal employees actually save you cost. Also, the test can be conducted much more quickly because usually your internal security personnel, they have a good understanding of the network. They know ins and outs of it. They know characteristics of your network. And for that reason, the planning phase takes a very short time. Also, the recon phase that we're going to talk about it later in this lecture about reconnaissance of the attack, it actually is kind of like the shortest possible. These guys already know everything about the network, right? So it happens more quickly. The other good thing is when you do it in-house, then you can use it to enhance the training of your other employees and raise awareness of the security risks for your internal employees. On the other side, there is one more advantage that you don't see on this slide, and I want to talk about it, and that's you don't need to trust anyone but your own employees with the critical information. So everything is just within the company. No vendor is going to know more about your network that someone from within the company knows. So that's another advantage here, keeping information within the company and not letting it leak out, because that company that has a pen tester has employees, then the employees get fired or leave that company. They may go disgruntled and all that. You have no control over that. But when you do it internally, now you know this employee is gone, you know how much they know, you know what type of information is going to be out of the play. The cons of this is, first of all, the inside knowledge may cause issue, because if you already have inside knowledge, that looks like you have the key to the kingdom already. So then you cannot really mimic a threat actor who is attacking from outside, right? Because, for example, if you have a honeypot in the company's network that's supposed to lure attacker there and kind of like divert the attacks to somewhere safe for the company, your insider guys, they already know that. They have that inside knowledge. So they're not going to get lured over there, right? So they're going to be more focused on the stuff that that may not really show your security posture against an external attacker. Also, lack of expertise. So the people you hire usually are within a specific pay range, right? You're not hiring high-end attackers. You cannot afford having these guys under your payroll if your company is not a pen testing company, right? Because you're not charging high enough to be able to pay these guys high enough. So most of the times you don't have all the expertise needed to conduct a full pen test in-house. And then finally, reluctance to reveal. This is one of the major problems, because that security personnel that finds that vulnerability may also be a member of the team that's supposed to do a good job and secure that system. So now they may think, okay, to maintain my job, to be able to kind of like show that I did a good job, I may not want to reveal this vulnerability. Or I have a friend in IT department who basically has configured the system, and I may not want to reveal that they didn't do a good job and the system is not secure. So all in all, there are pros, there are cons, and no matter you do inside pen testing or you hire a vendor to do that, you still need to trust the people who work for you to a certain level, right? But always have it in mind that they may be reluctant to kind of like give you information about who hasn't done a good job. So when it comes to the external pen testers, usually you get good advantages. These guys have the expertise, because when you want to pen test, let's say a set of Linux servers, you go to a vendor which is specialized in that area. So they have the expertise within the house, and you don't need to just be limited to your own employees with their sets of expertise that may not necessarily be what you need. They usually have good credentials, experience, and they have a focus on what you're asking them to do. So sounds like you're going to get a better skill set, better power on the pen test process. However, a disadvantage there is the information that you have is going to be uncovered by somebody else. A contractor, basically, who conducts a pen test on you, learns everything about your network. And later down the road, they may reveal it, right? So that's important. Also, sometimes they can sell this information to a competition. when they get all the information about your network, because they will be freely doing a recon on your network. And they're going to gather maybe more than enough information that you want to have out there. So again, as you can see, pros and cons happen over here as well. The other thing you can do, and is becoming kind of like, let's say, popular these days, is the bug bounty. So basically, put a bounty out there and say, hey, whomever can break into my system, this is the reward for them. Actually, years ago, a car building company in Sweden, Volvo, just went out and suggested that if you can break into our servers, we're going to give you a brand new Volvo. And guess what? A lot of people did that. So in a bug bounty, you just put a reward and say, hey, if anybody can reveal a vulnerability in our system, software, application, network, whatever, they're going to be obtaining that, right? And then these guys basically are going to work on your system. The advantage you get is faster testing, because everybody's going to start testing your system. And therefore, you can find the vulnerabilities faster. This is pretty good for software development companies, that their software is out there and everybody has a copy of it, right? Usually it's better on softwares and applications rather than networks, right? Because you don't want unlimited amount of attack come to your network, because it's going to bring your network down, right? So even though that can be the case, but because of the denial of service that can happen when everybody in the world is trying to break into your company's network, they try to conduct this mostly on software vulnerabilities or application vulnerabilities that everybody has on their computers, and therefore they're not going to bring your house down. The ability to rotate teams, so different individual test the system with different skill sets, so that you can have the opportunity of different perspectives trying to break into that. And the option of conducting multiple pen tests simultaneously, because they all have a copy of your software at home, they all have a copy of Photoshop, let's say, and they all are trying to break into it at the comfy of their couches. So let's have a knowledge check. So let's see who can answer this. What is the first step in penetration testing, and what is its importance? Read to the end, and then tell me what do you think is the correct answer.
A.
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 Why not D?
Mainly because this specifies the lack of planning could result in legal issues with crossing that white hack into the black hat hacker.
Right. And why this one is not correct?
I mean, that's the opposite of planning. If you just
Yeah, exactly. Like, this is an oxymoron, right? So even if you haven't read this document, haven't been in the lecture, you can see it says planning is the most important, but then it says it can be a skill. So yeah, good. So yeah, the correct answer is A, right? Planning is the first step and is not an optional step. Remember, a lack of planning can result not only in poorly defined penetration tests, but also in the legal issues, which means you're going to be dealing with FBI. So it's not fun, believe me. So next thing that we're going to discuss are the rules of engagement, right? So these are basically the constraints and the boundaries of the pen test. And these should be super clear right off the bat. And these come to the planning document that you have. So the categories that we are looking at when it comes to this is timing, right? When are you going to be conducting the pen test? For how long? What is the scope? How far are you going to go? Are you going to do only north-south, or you're going to do east-west? Are you going to just get in, or you're going to do lateral movement, right? The authorizations, what are you authorized to do, what you're not, the exploitations, what you will only just reveal, what you will also exploit to give a proof of concept, how the communications happen, when would you tell me if you found anything? Is it going to be instantaneously? As soon as you find it, you report, or it's going to be a report at the end, or I'm going to pay you before the report, blah, blah, blah. And next thing is cleanup. You clean up after what you do. You basically remove all the applications you have put in and all the tools you have put in. And finally, the reporting. So the following slides are going to be talking about this more in details. So let's go in and start with timing. So when the testing will occur is one of the important parameters that you want to set up. Like you're going to start early morning at 7 a.m. and then you're going to start at 10 a.m. The reason for which, guys, why do you think the entity actually, let's make it a discussion. Why do you think the entity needs to know the timing? If I'm the IT administrator, why do I need to know the pen testing is happening from 7 to 8 and not from 10 to 11?
So that way the system, that way they can be like, if they're alerted through the system that something's happening, they know that actual penetration testing is happening.
Right, that's one of the very good reasons. And the other reason is you want to make sure the pen testing is not happening at the time that your critical business processes are happening. Because the pen testing can bring the house down, right? And you don't want to do it when your company is basically doing critical activities. Usually you want the pen test to happen outside the business hours, right? So the scope, we want to define the boundaries to the environment, external and internal targets. What is the target, locations, and any kind of limitations like that. A lot of time when they allow a pen test to happen, they don't involve their critical databases. They don't involve their classified documents like restricted, confidential, and those type of classified servers. Right, so it's important. Just have a scope, make sure everybody understands what is to be tested and what should not be tested. So the authorization, as we discussed, is the receipt of prior written approval to conduct the pen test. So you really need them to tell you in writing that you're authorized to pen test them. Otherwise, you're hacking them. You're not pen testing them. So it's like walking a fine line of legal constraints. Right, make sure that signed document is obtained before you will start attacking anybody's system, application, or network. So the exploitation level, right? How far are you going to go in exploits? If you were able to exploit the firewall, are you going to go ahead and exploit the web server as well? Are you going to bring their application down? Are you going to make their website go down as well? These are the things that has to be done. I mean, be clear. So the communication, right? The pen tester should communicate with the entity, and any occasion, any kind of finding, any kind of risk that they discover should be communicated. And they have to let you know when they initiate. So basically, usually they send an email, say, hey, dear IT administrator, the pen test is beginning now. So they know it is happening. If there is any incident, they're going to report it to you for the incident response. Hey, we're trying to work with that system. We're sure that system is down now. Take a look at it. In case of an emergency, they should be able to communicate, initiate it, send it to you, or let the specific parties know as you define in the agreement with them. And finally, reporting the status. Usually, we like to receive a daily or every other day status. Okay, today we conducted 3 hours of pen test on these subnets of your network, and what we found initially was this. This is a raw draft, the final pen test report to follow, and so on and so forth. Then comes cleanup. You have to define the rules of cleanup. It is clear that any pen tester must ensure that whatever tool they have used should be removed. Sometimes, especially for the bigger entities, they want to install Assessment device, usually they grab a small laptop or one of these Intel boxes, a small computer boxes. They load everything that they need for pen testing onto the device. Something like an operating system like Kali Linux, Kali Linux, and the tools that they need. And then they usually open an SSH to it from outside the network, and they want that to be installed in the network. Sometimes they even need to have firewall exemption for that. So that's box or test box can actually communicate with the targets in the network, right? So all of those need to be reverted, right? Specifically, if you have any firewall rules applied to facilitate the pen test, you want to revert those firewall rules so your network goes back to where it was. So basically, as you can see here, removing all software agents if they have installed any software agent, like sometimes they need to have PowerShell enabled on all the systems, but you really don't need to have PowerShell enabled, right? When it's done, that should be disabled again. If they copied any script or executable binary or temporary file into any kind of system, that should be removed. If during the pen test they dropped a backdoor or a Trojan or a malware to any of your computers to exploit even more, those should be cleaned up and removed. So in the planning or the agreement you have with the pen tester, these should be clearly defined, so you don't end up with a system that actually has a lot of issues associated with it. So if they have been any credentials assigned, like if you added them to your Active Directory so that you can allow a credentialed test, and we're going to talk about credentialed and non-credentialed tests very soon. So if you allow the credential test, now you need to kind of like remove that, disable the account that you created for them, right? So all of these must be cleared. Finally, on reporting, once the pen test is complete, now you have to receive your report, right? A good agreement, a good pen test contract is the one that you sit down with the vendor and define what do you want to see in your reports. You want to see, like a lot of time, you want to see a proof of concept. You want them to prove it to you that, hey, if we say this attack is possible, we have a proof of it. Look, what we did was we dropped a text file into that location on the computer, which says, excuse me? Was there a question, guys? Okay, cool. So if you're not talking, please keep yourself on mute. Anyway, so you want them to give you a proof of concept. Hey, I copied this text file to that folder in such computer that says so and so, stuff like that, right? Usually those reports, and again, this is not de facto, this is not 100% rule of engagement. It all depends on the case, your entity, the pen testing vendor, and all that. However, usually you want to have an executive summary so that it is targeting the C-level managers of your company, those who are not really technical, like your CEO, CFO, all those guys who make big decisions and they cannot understand the technical details. So that goes for those audience, and the other part should be super technical so that the security professionals and possibly your internal pen test team be able to understand and take advantage of the information that is revealed, right? In most of the cases, what happens is the internal pen test team works in collaboration with the pen testing vendor in order to get the pen test done and all of these items actually be resolved. These guys, the internal pen testing team you have or internal security personnel you have, are closest to the topic and subject, and therefore they are going to have the best understanding of what needs to be done and how it needs to be done. So they're going to be the forefront of engagement. Take a moment and look at this pie chart. I'll give you just 1 minute to look at it, just read the legend and see the vulnerability type so we can have a quick discussion of this. So first of all, this is not a report that I can tell you is valid today. But generally, the results are in this realm. So most of the vulnerabilities we find as a result of a pen test are for missing patches. I don't like to talk about the numbers because these are changing every year, every month. But let's just look at the proportions, right? Most of them are missing patches. Very easy to be installed. However, a lot of companies have a patch management plan that doesn't allow the patch to be installed immediately. I think I talked to you before about the companies usually have 3 different environments. They do have a production environment, a QA testing environment, and a development environment. So dev, QA, and prod, these 3 environments there, which when the patch comes in, it goes to the QA environment first, it gets applied there, it gets tested there, a regression testing basically, to make sure this is not affecting the other functionalities, and this is not creating a new vulnerability, which may be even worse than the previous one. And then they're being transferred to the production environment. So a lot of time there is a delay between when the patches get released and the time that they actually get applied to the production environments. And that's why you see a lot of those missing patches in most of the production environments, no matter what system you're working with. So the other one, the next big contributor is lack of OS hardening. So they install the OS, they install the operating system, and they don't configure it properly. So a lot of services that they should not be enabled are enabled by default, and therefore your system is going to be vulnerable. Like when you install a copy of Windows, and by default your IIS, Internet Information Services, is enabled, and that can be compromised because you're not even using it. You don't even know the service is running behind the scene, and an attacker can actually compromise that for you. Next one is network design flaw. That comes from the poor design of the network, not considering segmentation, not considering perimeter protection, having the backdoors between different environments, right? Like between utility, between user environment, user land, and the data land, the data environment. When you don't manage the communications between different environments, then movement between environments become easier, and the foothold in the weaker environment can lead to the attack even on the stronger environment. Application hardening, same story. You have a very hardened operating system, but now you install application that has many flaws. So that application may turn into a foothold for the attacker to compromise the entire system. Weak passwords, that's another big contributor, right? Not only weak password, but enforcement of super strong password, right? When you enforce super strong passwords, what happens is people find a way around it because they cannot memorize it. They start writing those down. They start putting them in a text file on their phone or something, which then is going to turn into an actually weak password. If you pick up their keyboard, flip it, and you see a sticker on their keyboard that has the password, that's what I'm talking about. The password may be very strong, but when I can visually see it, good luck with it. It's not a strong password anymore. And of course, other vulnerabilities are out there, right? Any question about these categories that we just discussed? Okay, cool. So we're gonna move and we're gonna talk about the performing a pen test now. So far we talked about planning for it, what needs to be in that plan, what needs to be considered. Now let's talk about the performance. So a successful pen test starts with determination, resolution, and perseverance, right? Determining what's wrong, finding the solution, and making sure we are following the maintenance of those solutions in a persevered way. Any pen tester can do whatever they want, but they always need to have a recon as the first step of the pen test. You have to find the point of attack. You have to find what point in this huge wall is the most vulnerable so you can attack there. So reconnaissance comes first and then the penetration itself. So reconnaissance also called footprinting, right? Which is the first step of any attack. Do you remember from last lecture that what can help you with finding vulnerabilities of a system without even touching your computer, without even having technology in hand? Anyone? If you guys are talking, you should be on mute.
Can you repeat the question? You cut off a little bit.
So the question that I have is, without even touching my computer, without even touching anything technological, I should be able to find vulnerabilities of a system through a process. Do you remember what that process could be?
Social engineering.
Thank you so much. That's the answer. So usually that is the first step. Like when the attack on Target happened 5 or 6 years ago, it was all through social engineering, where the attackers figured out the FireEye upgrade is going to happen at that specific date, and then they plan their attack for the day of upgrade, right? So you can do active recon or passive recon to obtain the information. The active recon involves directly probing the vulnerabilities, right? So in the past, we had war driving only. Now we have war flying. As soon as the drones came out, we started using them for war driving, which the name then transferred into war flying, right? So war driving or war flying is moving around and finding the wireless signals that can be compromised, right? So you can fly your drone over people's houses and figure out where you can find a vulnerable wireless access point to compromise. You can ride in your car around the neighborhood with the Kali Linux, with the interface and monitoring stat, and basically find these vulnerable ones. So disadvantage of active recon is that when you're probing, you may alert the security professionals. If you start flying your drone over, I don't know, a branch of company X, security professionals are going to be suspicious. Hey, what's happening? Someone is trying to do something. If you're sitting in a parking lot with an old laptop and a huge antenna on your wireless access point or wireless adapter, then you may alert people. So active war driving may alert people easily, and they either question you or they can figure out an attack is actually supposed to happen. So the passive recon basically occurs when you use tools that they don't raise any alarms, right? Like automated tools, right? You can just search online for all the open source intelligence that you can find. You can go to dark web and actually purchase the information you need with a bunch of Bitcoins, right? And so on and so forth. So when phase one is finished, when you do recon, when you know, okay, company so-and-so has this vulnerability, and just piggybacking on what we discussed earlier in this lecture, remember we said, when you give pentest contracts to the third parties, to the vendors, and these vendors actually conduct a test, they know more than enough about your company. Now, one employee of that vendor can go to the dark web and simply just sell that information. And that's where you can find the recon information that you need to attack company X. So when the pen test happens, basically it happens either through using a specific predefined tools or just running the creative tools that the pen tester designs themselves. But at the end of the day, they want to simulate the actions of a threat actor. So they're going to start thinking like a hacker, maybe a black hat, and they're going to start compromising as much as they can, or at least revealing the vulnerabilities that can be exploited. So the initial compromises usually don't contain the data that is the goal of the attack. They usually contain the data that is needed to plan the final attack. So you don't need to necessarily, if you're supposed to compromise server X within a network, you don't need to just start attacking server X, no matter where you're attacking. You may want to start compromising a firewall first. Let's see if I can compromise this firewall. And from that firewall, you want to move to another one, which is closer to server X. And then from there, compromising server X. So there come many different stages here. I don't even want to talk about the specific steps, because this is really a creative process. This is the kind of like artistic, which route you're going to take, which can give you more privilege, more advantage over the final goal that you want to compromise, right? So basically just hopping and moving laterally or in depth. We have two types of movements, right? Moving in depth is getting closer to the target. Moving laterally is moving within the same subnet horizontally and not getting closer to the subnet, but finding a better foothold to go down. Sometimes moving laterally is referred to as moving east-west, and moving in depth is referred to as moving north-south, right? So for the direction. That's actually a common terminology in enterprises. They just refer to it as that. So there are some lessons to be learned from how threat actors work after the pen tester tries actually to compromise that. So when a vulnerability is discovered, the pen tester must determine how to pivot or turn to another system. And this is exactly what I'm calling lateral movement or movement in depth, right? Using another vulnerability to continue moving towards the target. So it's just traversing a grid, sometimes horizontally, sometimes vertically, till we get to the deepest depth. Vulnerabilities that are not part of the ultimate target can still provide a gateway to the target. Of course, we're going to report those as well, but those are not the final goal. So pen tests are manual, therefore a pen tester needs to design attacks carefully and artistically. Pen testers must be patient and persistent. So it takes time to pen test the system, right? Especially when it comes to enterprises. There are times of the day that the systems are more vulnerable because of the processes that happens in the network. Even some network maintenance processes can help a pen tester to attack a system better. For example, restarting a server makes that server vulnerable throughout the process of restart. And if you can figure out when the server is being restarted, you're going to have a vulnerable server for at least a minute. And for that reason, you have to be patient, sit down, slow down, have your coffee mug, have your drink, and persistently run the attacks and look for the possibilities of getting in. Let's do a knowledge check together, guys. Let's see who can answer this question for me. What are two primary phases of penetration testing in the order?
Recognize the penetration.
So answer D, right?
Yes.
Okay, great. Looks like everybody was listening. Yes, that's correct. Reconnaissance and penetration. So we already discussed that. You first need to find the information needed and then conduct the penetration. So at this point, we had our discussion about penetration testing. So let's stop for this point. We're not going to talk about pen test more, and we're going to switch gear and talk about vulnerability scanning, which basically is complementary to a pen test. And this is what our internal security personnel can do. Most of the time, companies have SIMs, and they have log and event management systems, which constantly looks at the systems, baseline the systems, compares with the baseline, and based on that, reveals the vulnerabilities which are available in the system. So this is a studying vulnerability of a system. So we are going to talk about what vulnerability scanning is, how to conduct it, and how to use data management tools. We're going to talk about a couple of them. As you know, our references with this book are vendor agnostic. So we don't have no vendor name here, but you know the biggest players here are Elastic, Splunk, and those companies. So we also talk about threat hunting and how it can help scanning. So let's see, what is a vulnerability scan? As the definition says, a penetration test is a single event using a manual process often performed only after a specific amount of time has passed and specific to a goal that is the goal of the test plan. However, vulnerability scan is happening frequently and it's an ongoing process. It continuously happens and identifies the vulnerabilities and monitors the cybersecurity progress and the posture of a network or a system. So basically, you do have frameworks that they know what the common vulnerabilities are. You go and test your system against those to see if those vulnerabilities are existent on your systems. And you do this on a regular basis. Like enterprises run these on a daily basis and they update the report. So at any given time, you go to the reports of the vulnerability scan, you can see what vulnerabilities are available in your system. The whole thing involves knowing what to scan and for how often. What is the necessity and frequency for this scan? Selecting a specific type of a scan that we're going to discuss about, and finally interpreting the vulnerability information that we receive. Sometimes something could be considered a vulnerability, but interpretation of it is different. Like Log4j, for example, is a Java programming language vulnerability. That's a library for logging in Java. And it was known to be a critical severity 5 vulnerability back in December. However, there are some systems that have Log4j in the application, but Log4j is not used as just a part of the library. So you have to be able to interpret the severity of the situation. Yes, it is still a vulnerability that can be compromised. However, it's not really severity 5 anymore because the application is not using it for logging in. Therefore, that de-escalates to severity 4 and so on and so forth. So someone with the knowledge or a system with a nice threat repository is needed in order to interpret the vulnerabilities. So for when and what, usually there are two primary reasons for not conducting around-the-clock vulnerability scans. Those interrupt the workflows because you're reading information, you're pinging every port, every IP address. And then the technical constraints. You may not have enough technical resources to conduct this around the clock. So a more focused approach is to know the location of data so that specific system with high value data can be scanned more frequently, and the systems with not high value data can be scanned less frequently. So basically focusing your resources where it provides the most value for your enterprise. So what you can see here are the vulnerability scanners, right? The security scanner application here that you can see, and we don't want to just talk about the application for sure, but usually you get a report like these so you can see how your systems are, how many of those vulnerabilities are out there, and what are the severities. Some systems like Brainca, they actually give you the ability to assign a ticket to an asset owner. So when you're within a network, especially in enterprises, each asset within the network has an owner, an IT SME, which is responsible for that specific asset. And more advanced and complex tools, sophisticated tools, actually, they assign tickets to the IT SMEs and asset owners to remediate the vulnerability after they are being revealed through the scans. So usually want to define a group of target devices, again, based on the impact, based on how impactful is the failure of those devices. Ensure the scan is designed to meet the intended goals. Like if you have a video wall, which the only role of that video wall is to show information and welcome the customers who walk into your headquarters, you usually don't want to scan that more often, right? But if you have a database which has customer PII data, personally identifiable information data, then you want to scan them more often, right? Determine the sensitivity level and the depth of the scan, and finally specify the data types to be scanned. What do you want to scan? Do you want to scan all the files on that system, or you just want to look at the configuration files, or you want to look at root files, core files, kernel files, and stuff like that? So that's going to be within your plan. So we do have major types of scan. You can categorize them into credential and non-credential scan. And credential scan, the scanner actually has the valid authentication credentials to the system. Therefore, it is like an attacker has taken over that system already. Now you want to see what else they can do. Non-credential scans, we don't provide them anything. So basically on those scans, if an authentication is needed at any point, that is going to be a stopper for the scan, and therefore shows us, okay, if our authentication, authorization, and accountings like the AAA of security are in place, the system is not going to be very vulnerable because we did a non-credential scan and we didn't reveal anything, or we didn't reveal as much as credential scan did, right? So of course, credential scan is going to reveal more because now you have deeper access. In another sense, and I don't like the way this slide is, so these two are just one way of categorization, and these two are another way, right? So the scan can be intrusive or non-intrusive. So intrusive attempts, they're out there to employ any vulnerability that they find, but non-intrusive scan does not attempt to exploit anything, right? So on the intrusive scan, you can bring the system down, you can break the system, because if you find a vulnerability, what would you do is just exploiting it. In non-intrusive, you're not going to do that. So when you find the vulnerability or any kind of result out of your scan, usually your automated vulnerability management system, which we're going to talk about them very soon, they're going to compare what you found with a set of known vulnerabilities out there. Understanding, okay, we do have TLS version 1.0 on our system. Let's see what we know about this on the databases of Meyer. Okay, so any questions so far? Anybody has a question so far, guys?
Hey, question, if the intrusive scan is exploiting vulnerabilities, does that make it closer to a pen test?
It is the closest
Or
pen
what's-
test, yes. Yes,
How is it distinguished from a pen test?
this is an automated process. Pen test is a manual process. Pen test has more limited the scope. This one scans a set of systems that you have on a regular basis.
Oh, okay, thanks.
Sure, sure. And it's a very good question. And let me just say this right here. Most of the definitions that we have and we're going through for getting a cert and all that, they're just to have a common language. The borders are really blurry. There is no like sharp line that you can draw and say, okay, this is intrusive, that is non-intrusive. You can actually have a non-intrusive pen test as well, right? But I don't want to confuse you guys with all of those. When you get into doing it, you will notice that the names are not really that important because they don't have a sharp and clear boundary. Does that make sense?
Yeah.
Yeah, there are a lot of overlaps, but very good question. I like it. Okay, good, good. So finally, we come at the examining results. So when we see the results, we can see the importance because we go ahead and compare it with the databases out there, like the Meyer vulnerability database, like all the CVEs, and we can figure out what is the severity of this vulnerability, right? So you have to go ahead and do a risk assessment right there, right? And you can see a set of questions that are on the slide. I'm not going to read it for you, but basically what you want to see is, first of all, what is the likelihood of this attack to happen? How many people have the ability to get this attack done? How sophisticated is the knowledge needed for such attack to happen, right? That defines likelihood for you. Okay, it's very likely, it's least likely. In the real life, if I give you an example, what is the likelihood of someone being able to break into a jewelry shop which has a lot of protections? And then what is the likelihood of someone stealing something from Best Buy presentation tables? You see, you understand what I'm talking about, that I'm saying likelihood, right? It's easier on Best Buy, everything is on the desk so they can grab it and run away. Actually, I heard the stories about what happened in San Jose when a bunch of kids, like 15, 20 kids, were walking into Apple stores and at one point altogether simultaneously grabbing an Apple device and running out. So most likely nobody was grabbing them, or one or two of them were stopped and the rest were running out. So the likelihood went so high that they started appointing police officers to the Apple stores. But let's say doing the same thing in a jewelry that controls the door, they boss you in, they don't let more than one person come in at once and all that, the likelihood is smaller, right? So all of that goes to calculation of the likelihood. And then next step is to calculate the impact. Okay, what is the impact of an Apple iPhone being stolen? About, let's say, $1,000. Now, what is the impact of a diamond ring of 2 carats being stolen? That's like $500,000 right there. So that impact is way bigger than the impact over here. And now that you have these two figured out, the likelihood and impact, if you multiply them, the product of this is going to give you the risk. So risk equals impact times likelihood, right? And usually we have this in a qualitative way, like we say, the likelihood is high, but the impact is low. So high times low equals medium. So the risk is medium. Then we go to the jewelry, the likelihood is low, but the impact is high. So low times high again is medium. So as you can see, the risk for both of them is the same. And if you want to think about it logically, they can stole many iPhones. And then that becomes a big deal, right? So anyway, analysis of the results is always there. And you want to be very vigilant when you look at the results, because one possible problems that you can always see are the false positive or false negatives, right? Which are the alarms that are being raised for no reason, or alarms that are not being raised for no reason. So you have to identify false positives so that correlate the vulnerability scan data with several internal data points so that you can figure out, oh no, this is a false positive. Like at the same time that we were doing the scan, a server was just being restarted, and that was during the restart time that the server showed a vulnerability on port 443. But after that, it's not there. Right? So that's basically all, again, coming back to you as the cybersecurity specialist to evaluate. Good news is, for all of these, we do have automated tools, right? The automated tools that they can scan, they can compare, they can give you the risk score, they can give you the severity score and all that for you just to make the decision. One that you're going to hear a lot about from now on are the SIMs, or security information and event management tools like Elastic, or you have the SOAR, security orchestration, automation, and response, which both of them are just automated tools that help you with aggregation, correlation, automated alerting, time synchronization, duplication of the events, creation of the logs, analysis of the logs, and preparing the reports, right? So this basically is an example of how a SIEM dashboard looks like, right? So they show you the current status of vulnerabilities, right? The SEV5 situation. They give you different type of representations of how your enterprise is actually doing. So when you go to these SIOCs, the Centers for Security and Information Management in any company, so they call it the SOC Center. When you go to a SOC, they do have big monitors on the wall that constantly shows some of these dashboards. So at a glance, they can look at it. And if a spike happens or a change happens, they can react to it. So SIMs, as I said, also give you the analysis. So they do provide sentiment analysis, which is the process of computationally identifying and categorizing opinions to determine the writer's attitude towards a particular topic, right? That means the SIMs, they look up, they go to different websites, they see how everybody's reporting about a specific vulnerability that your system has, what type of attacks are happening. Even they look into the forums to see if they're talking about the possible exploits about this attack. And actually at the end, they're giving you a report on how severe is the risk of this attack, because they calculate the likelihood based on what they find in the world out there about that specific vulnerability. So SOARs are also similar to SIM, and they combine more comprehensive data. So these are more comprehensive data. They have better analytics, and they automate the incident response, because when you have any of these vulnerabilities being exploited, they automatically provide the steps and plans for addressing those. And we're going to talk about the incident response, business continuity, and disaster recovery later down this series of lectures. So bear with me on those. We're going to just dive deep into all of those. Next topic that we're going to talk about is threat hunting. Basically, it's going out there and hunt for the threats, right? And these threats that we want to hunt for are those that have not been revealed so far, right? So it all begins with a critical premise. Threat actors have already infiltrated our network. So they are in our network, right? So then it proceeds to find unusual behavior that may indicate malicious activity. So I'm going to go and scan the throughput to the network from all the computers in my network, and I'm going to compare it to previous days. So if John Doe's computer used to use only like 10 megabytes for the entire day, and all of a sudden John Doe is using a gigabyte for the entire day, there may be a threat. So now I hunted the threat down. Now I'm going to go and evaluate John Doe's system to see, okay, why this high spike in the traffic usage is happening. That's only one example of it, but I think you understand what does it mean. So again, attack has happened. You're looking to see what is not normal. Or like if your SQL server is being used by a client that has never used it before, now that can be a sign of a threat, right? Threat hunting investigations often use crowdsourced attack data, such as you do have the advisories and bulletins that are out there. We compare with those. We look at the threat fits somewhere like Myra, CVE database and all that, or informations from a fusion center, which is a formal repository of information from enterprises and government use to share information on the attacks. One good example of it is the NIST database, right? So all in all together, as you can see, we all compare whatever we find with what is out there known about them, and people already have looked into it. But that doesn't mean that you always are going to find the stuff out there. Can you guys, considering the discussion we had last week, right? Can you give me an example of when you possibly are not going to be able to find anything about the attack out there in the databases?
0 day.
Thank you. Awesome. Love that answer. On a 0-day attack, you're not going to be able to do any of these. So you're the first person to report those to the databases. So actually everybody else comes after you. Let's do a knowledge check. Can you guys answer this question for me? Which of the following is not typically a feature of a SIM? Anyone?
Remediation.
Thank you. You're doing very good tonight. Okay. The answer is remediation. The SIM is not remediating anything. The SIM only tells us what is wrong, and then that is our role to go ahead and remediate that. Very good, very good. So for the rest, we want to talk about different resources which are out there. We're going to talk about this more in the future lectures of this series. But over here, we want to talk about different frameworks, regulations, standards, legislations, benchmarks, secure configuration guides, and finally, IS or information sources. A cybersecurity framework basically is nothing but a series of documented processes that we use to create the guides, policies, procedures, and implement security controls in our environment. The most commonly known ones are NIST, National Institute of Standard and Technology. This is basically the most widely used framework in the United States. As far as I know, even huge utilities are using that. We have ISO, International Organization for Standardization. They do have ISOs related to security, but they're not as comprehensive as NIST. American Institute of Certified Public Accountants, or ISPA. This one also has security directives and controls, but again, not as complete as NIST and not as comprehensive as NIST. We do have the CIS, Center of Internet Security. They also have, you know, if you look at them, besides NIST and CSA, none of them is 100% security targeted. They have other stuff also in their basket, right? So security is something along with the others, but Cloud Security Alliance, CSA, and NIST, these two frameworks basically are 100% focused on security. NIST, which is one of the most commonly used ones, has a CSF function. So the functions in NIST is identify the threat, protect against the threat, detect any kind of exploit, respond to the exploit, and recover from any disaster, and go ahead and do identify. So it's iterative. We always go through that. These two are about the threats. These two are about the exploits. And this finally is recovering from an exploit. When you go to NIST website, you're going to find many NIST standards. One of them that is commonly used is NIST 883-11, which gives you controls for different type of security situations. The controls that if you apply to a security system is going to keep it secure against the possibility of exploits of the known threats. We're going to talk about NIST more in future, so I'm going to put it there for now. That was just an introduction of the NIST. So then we come down to regulations. Obviously, like any other type of regulation, the process of adhering to regulation is called compliance. And you always hear that from security specialists that, hey, you're not in compliance with NIST controls. Hey, you're not in compliance with TSA controls, right? So industrial regulations are typically developed by established professional organization or government agencies using the expertise of seasoned security professionals. One of the entities that actually you may not guess as providing security controls to huge enterprises, like even utilities like PG&E, is TSA. The same TSA that checks you in the airports before you onboard the plane. So they actually provide regulations to for the security as well. So some of these categories, as you can see down here, are broadly applicable regulations, industry specific regulations, US state regulations, or even international regulation based on which compliance zone or region you are in. For the legislation, so specific legislations can also be created by governments. Usually they can be just a statewide, territorial, or just for the entire United States. Due to lack of comprehensive federal regulations for data breach notification, many states have amended their breach notification laws from the basic definitions that are out there. And it's funny that no two states in the United States have the same laws for information breach. So isn't that funny? So state to a state, you may be, in one state you may be criminal, in the other state you're not. So that's how it is. So when it comes to the standards, those are usually the documents approved through consensus by the recognized standardization bodies. One of these in cybersecurity, one example is PCI DSS, which is pertaining to the credit card payments. One of their controls is you cannot save credit card information. The PAN, the credit card number that you have is called the PAN, right? So the PAN and date of expiration cannot be kept in the same database at the same time. So if someone is able to recharge you without your consent, they are out of compliance with PCI DSS. So unless you ask them to save that information, they are legally required not to save those informations in the same database. So they have to save it in different databases so that you actually, in case of a compromise, all your critical information is not lost. We also have benchmarks or secure configuration guides. These are just guides that are distributed by the manufacturers or the developers themselves on how to configure your system so that your system is not vulnerable. One good example is docs.microsoft.com, where you can go to Microsoft documentation about different products of Microsoft and see what is the best and most secure configuration way to deal with Microsoft products, right? Those guides usually come for anything from physical layer of your network, like infrastructure devices such as routers, switches, and all those. They're also available for operating systems, different type of applications and operating systems that are out there. Information resources are also available to you, right? There are a variety of those, from anything from the vendors and information vendors provide about, okay, we found this vulnerability in our system. This is how to address it. This is how to go for it. All the way to different conferences you can go, like in Las Vegas, every year we do have the DEF CON. That's all the hackers from around the world gather and just share information and kind of like get synced up. To the journals, to the papers, the scholar papers, industry groups. You can even find those on Twitter, anywhere. Like these days, if you are a security specialist, guys, you have to be all over internet, all over news, all over sources, and update yourself on a regular basis. You just get out of sync for a month or two, you're going to be a fossil in this business. So it's important to be very familiar with these resources and use them, right? Also, you can use the RFCs or requests for comments, which are just basically white paper documents that technology bodies create. Like engineers create RFCs, experts create RFCs. There are RFCs over the attack on target. There are RFCs over vulnerabilities of the FireEye. So those are the documents that experts create are out there. Most of the time you have to pay to read those, but you can also find those for free on the internet. So, any questions so far, guys? There is a self-assessment that you can do it if you have access to the book. I'm not going to go over it as a part of this lecture, but let's go to the summary and see what did we do in this lecture. So we talked about penetration testing and how it is being conducted and why it is being conducted. We talked about using internal security personnel to conduct a pen test, and we talked about pros and cons. We talked about rules of engagement in pen tests, and we talked about the phases of penetration tests. We talked about planning, footprinting, recon, all of those goodies, and then application of a pen test. We defined pen tests, and we talked about their processes being manual, being creative, being artistic. We talked about vulnerability scanning, and we talked about what they provide to us as the system owners. Then we talked about the management tools. We talked about SIM and SOAR, what they're good for, what they can do, and what they cannot do, which one of you guys correctly responded, remediation is what the SIM doesn't do, right? Then we introduced the framework. We talked about NIST as being the top of the line framework as it is adopted by many industries now. We talked about regulations, the standards, RFCs, documentation that we get. And basically we covered both topics of penetration testing and vulnerability scanning in the second lecture of Network Security Fundamentals series. So at this point, I'm going to stop the recording